Hi class, in this video we'll learn about NPV, IRR. NPV is obviously known as net present value and IRR is internal rate of return. So before starting it, let us briefly understand, uh, how this problem is set up. So we have initial cash outflow of rupees 2 lakh at the initial time, and after 1 year we are getting 30,000, and then year 2 we are getting 40,000, year 3 we are getting 60, same in year 4, and then year 5 we are getting 80,000. So there's one single cash outflow, and there are 5 cash inflows that we are expecting here. Now, discounting rate, inflation rate, you can have, as per the scenario, as per the economic setup. In this particular given question, let us take that it is around 13%. So if manually we would have done it, so what we would have done to calculate the net present value, we would have started calculating the present value factor. So the present value factor is normally calculated by this formula, 1 divided by 1 plus the inflation rate, and I have to freeze it because I'll be dragging the formula further. So I'm just freezing it by pressing F4. In some of the laptop, it might be function plus F4, and then closing the bracket, raising it to the power time. So the time factor is here. So this is how you set up the formula of present value factor, and you just drag it down, and you'll come to know what is your present value factor over here. So the idea is, if you convert it to 10%, it will give you the present value factors at the rate of 10%. If you have 9% discounting rate, the present value factors will automatically update because we have linked this particular calculation accordingly. So now let's say this is the present value factor. Now, if I want to calculate the discounted cash flow, the actual cash flows are already there. So if I want to calculate discounted cash flow, so that is simply the annual cash flow multiplied by the discounted cash flow. So this is what I can normally try and do. So this multiplied by this, and accordingly I can calculate this on calculation, and this will give me the discounted cash flow for each year. Now let us quickly understand, what these values are actually signifying. So 1 rupee, equates to 1 rupee today, because that is how the present value of money is actually calculated. Today's 1 rupee is equal to 1 rupee without a doubt. But after 1 year, if the money discounts at 13%, that 1 rupee, will be valuing around 0.885. Now, what does it mean? That you'll be getting 30,000 rupees, but if you see, what is the present value of this 30,000 rupees that I'm going to get after 1 year, that is actually 26,548. Another example, 1 rupee, after 5 years, discounted at 13%, will actually become 0.543. That itself tells you'll be receiving 80,000, over the period of 5 years, after 5 years. But the present value of this 80,000 rupees will be 43,420 rupees. So that's something we need to understand. I believe that much of understanding is there. So ultimately, if you see in this project what's happening, if I'm just taking AutoSum here by using called plus equal to, so the moment I enter, so actually I'm making 70,000 rupees profit. It appears that I'm making 70,000 rupees profit because the total cash inflow is 2,70,000, and the value that I'm paying right now is 2 lakh. But here at the end I'll be saving 70,000 rupees. But if I calculate the net present value here, so this becomes negative. The value is negative because 20,322 rupees, you are in loss in terms of present value. So 2 lakh rupees you are paying today, that is worth, equal to 2 lakh rupees. 30,000 that you'll receive after 1 year, that is equivalent to today's 26,000 rupees. 40,000 rupees to be received after second year is equivalent to 31,000 something of today. So every amount that you're going to receive in future has a discounted value, in terms of today value. So this is how you actually, you are going to lose money. However, if you reduce your discounting rate, like the inflation rate is prevailing around 11%, now you have, again, still your NPV is slightly negative. If the inflation rate or discounting rate is around 8%, for example, so then we have a positive NPV. So because the formula is placed there and the calculation that we are doing is giving us that answer. So this is the basic concept of net present value. So in short, what we could understand here, that we got 70,000 rupees It was evident that we are getting 70,000, but the present value of the difference in what I'm paying and what I'm getting is 8,249. When the discounting rate is 8%, when I make it 13%, it goes negative. Now, if I want to use Excel function for this purpose, I have to use NPV. And in NPV, what I'll do, I'll take the discounting rate first of all. And most of the time, the mistake that will be committed by most of the students is like this. They start doing selection like this. And this is like the entire range of value. Definitely it is, but it is not the correct way to calculate NPV in Excel. So the moment you'll do that, you'll get a different answer. So what I should do to get the exact answer that I'm getting in my physical calculation. So I'll just tell you the way out. NPV function in Excel actually is designed for discounting the basically outflows that are starting from period 1. So the first period is 30,000. It has to be multiplied with the present value factor, which is 0.885. So the NPV function in this Excel is designed in a way that starts calculation. If you put the first value, it will assume that it is after 1 duration. So that is how the formula is configured. So what I'm doing here, I'm selecting from 1 to 5 or whatever your duration is, and then you hit enter. Now it is going to give you the discounted cash flows total. You can just check it here. If I'll just merge the column over here, and if I just take some of the discounted cash outflows from some of the discounted cash inflows from me, so this value comes 1,79,677.47. Exactly what I'm getting in my NPV answer. So if I want to calculate the discounted cash inflows present value, then it is perfect. But if you want to calculate the exact NPV what you have read in the books, and you want to calculate that net present value, so you have to add the initial investment into this, because it's a negative number, that's why I'm adding, and then hit enter, and then you'll get the exact answer what you were getting in your manual calculation. So this is something like you need to understand when you apply NPV function only. So you get basically what? You get basically this particular value that is actually denoting what? It is the sum of discounted cash inflows that you have actually in this particular series. So that's one takeaway. Now, if I want to calculate IRR, what is the IRR and how does it affect my things? So internal rate of return in simple words is a rate at which NPV is going to be 0. So I'm looking for a rate that is actually there, which is a cutoff rate. Any discounting rate less than that, this IRR, is going to give me a positive NPV, and any discounting rate above this particular IRR is going to give me a negative NPV. So that is something, the concept that lies behind. Let me just do it, and then I'll re-explain this to you. So let me apply the function here, IRR. And I'm not going for the manual calculation of IRR, it's a lengthy calculation. So I'll just explain you the concept over here. So IRR I'm using, and what are the values here? So the values are here, minus 2 lakh to 80,000. This is my entire cash flow cycle. Here we have to take the very first value as well, that is my cash outflow. So I'll take minus 2 lakh along with all the cash flows. So please remember, one number has to be negative. Out of this, it is not necessary that only in the beginning the outflows will be there. It may be multiple times during the project, but at least one negative number has to be there to calculate this number. So if I just enter here, and it is asking me for any guess, I don't want to make any guess, I want concrete answer. If you will guess, it will not affect the entire calculation, because this guess is in the large bracket, which is an optional syntax parameter. I'm not using any guess value, I'm just hitting enter over here. So I get one answer, which is like 9.33% is my IRR. Now what does it mean? Just try and see that. If I just write 9.33% over here, so obviously this will give me some sort of value here, some residual is there. So if you just increase these three values like that, it will eventually get down. So ideally what we normally do, if I want to exactly see the value, so I'm just equating to this particular value, because all the decimal points are there in this Excel sheet. So this eventually becomes 0. My NPV has become 0 now. That is the important takeaway. So my NPV has become 0. So IRR is that rate at which, when I discount my project outflows and inflows, my net present value becomes zero. Now the idea is, if the project has IRR of 9.33%, so if I discount on a rate which is less than 9.33%, I should get a positive net present value. So if I say 9.3%, I get some minimal positive NPV. So at least I'm earning 206 rupees over there. So if I say 9%, this value will keep on rising. The moment your inflation is lesser than the IRR, your NPV is going to be higher. So as you reduces the rate, your NPV goes up. So if the inflation prevailing in the market is just 4%, you make 36,000 in terms of present value. So this is how the entire equation is working. But the moment your inflation rate is above the IRR, you will have a negative net present value. For example, if I say 9.4, slightly above this IRR, you will have a negative net present value. So whatever you'll pay in today's time, whatever you're going to get in future has a lesser present value than what you are paying today. So this is the concept. This is the concept. So IRR is basically that particular rate of return, which eventually gives you a cutoff rate, which you can actually compare with the inflation rate. So if inflation rate is higher than the IRR, you'll get negative value. So if I make it 10%, you'll get further negative. If you keep on increasing it, you will keep on increasing your negative net present value. So obviously, we don't want to go and select a project which has a negative net present value, because we are paying 2 lakh and we are getting less than what we are paying today. It's not a good idea to invest in this kind of project. So this is the concept of NPV and IRR. In the next video, we'll continue with the concept of XIRR and XNPV. Thank you.